All right, so we have the production function, which is the function that as we add more input, we get more output, but at a decreasing rate. Now, associated with that comes the total cost curve, and that's the fixed and the variable costs together as we increase production. And we're going to look at how that's derived now. Let me pull up a marker here. All right. So in this case, you can see here's a table showing your variable and fixed cost and then the total cost on this side. I wish this wasn't covered up, but it is what it is. And this is 80 and 90, of course. Okay, so what we have here is on day 0, we have 0 output. There's no marginal product of labor, no worker made anything. The fixed cost is $30. The cost of the workers is 0 because there are none. The total cost to the factory is $30, which is just fixed cost. All right, the next day we come in, we hire a worker, and we get 50 units of output. So the marginal product of labor is 50, but it's also the total output for that day. The cost of the factory on the second day is still $30. The cost of the worker is $10, and the total cost is now 40. All right, day 2, we come in, we have another worker, so I guess 2 workers, day 2. Then that second worker contributes an additional 40 units of output here. And so now the total is 90. It's just 50 plus 40. Fixed cost is the same. The wages now are $10 per person times 2, and the total cost is now 50. One little thing to say here is that, and it's a reasonable question, is that if if there's like economies of scale by hiring a couple of workers, which there probably is, at least initially, is that if you're experiencing diminishing marginal product, it's probably just divided between the 2 workers. It's not one can produce 50 and the second produces 40. It just means that each of them decreases in their ability just a little bit. And the reason for that is that as we, like the first worker, he or she can come in and do whatever, they can use the ovens and use all the pans and do whatever they want. But when you hire the second worker, they have to kind of watch out for each other. And like maybe this worker has to wait for the oven for a little bit, or, something along those lines. All right, so one more just to be sure. So the next day, 3 workers. Total output is 120. The marginal product of labor of the third worker is 30. The fixed cost is exactly the same. The wage cost is $30, and our total cost is 60. All right, so the cost curve now starts to get built, and so let me go ahead a little bit so we have something to look at. Okay, so what happens is you can see here on day 0 or day 1, if whatever, that before any production starts, we have a total cost of 30, and that just represents the fixed cost. That's all there is because there's no workers to be paid. The next day you hire a worker, their marginal product of labor is going to be 50. They now have a variable cost of wages, so it takes the total cost for that day from 30 to 40. It's the 30 of the fixed cost and then 10 of a variable cost. Next day the cost goes up to 50. You're paying 2 workers $10 each. The output increases to 90, and then of course the marginal product of that second worker is 40. Next day, $60, which is 3 workers at $10 a day. The total product is 120, and the marginal product of that third worker is going to be 30. All right, so we have basically the 3 costs we've talked about are fixed cost, variable cost, and total cost. So that's pretty straightforward. That's, you can do it by columns and add them together. You can just divide by the number of units, however it works for you. All right, so now we're going to add in a couple or 3 other things, and you can see here it's average fixed, average variable, and average total cost. All this is taking the fixed cost and then dividing by the units of output. And the average fixed, average costs tend to rise at an increasing rate, and I'll show you an example of that in just a second. So average fixed cost, you take the fixed cost, you just divide by the units of output. Average variable cost, you take the variable cost and then divide by the units of output. Average total cost is the total cost, which is this, the summation of this plus this. And then, like I said, you can add this and this and this together, or sorry, this and this to get this, or you can just take the total cost at this point and then divide by the units of output. It kind of depends what works better for you, but it's really not that complicated. All right, so let me show you what that looks like. This looks terrible, but it's really not that big a deal. So we'll go through a few lines, and there's a quiz question related to this. It's not this complex, but sort of getting the sense of how these all work together is probably going to be really useful for the couple of questions that pertain to. All right, so day 0 or day 1, no, day 0. Lemonade now. All right, so we have a fixed cost of $3, and that's the rental of the kiosk or something. There's no variable cost. The total cost is 3. We'll get into these in just a second. All right, so day 1, the fixed cost is 3 here. We have a variable cost of 30 cents. We have a total cost of $3.30, which is this plus this equals this. Next day, these again are the fixed, variable, and total costs. Next day, the fixed cost is the same. The variable cost is now 80 cents, diminishing marginal product, and it's just, I mean, with a lemonade stand, you'd probably have some big economies of scale right off the bat, but you know, just kind of go with the flow on this one because the principle is what we're looking for, and it holds true. I've tested it myself, and it holds true. Every time I've done it, it's the same result. So this is a little extreme, but it's just to get the point across. All right, so $3 plus 80 cents of variable cost, total now is $3.80. Next day, $3 in fixed cost, $1.50 in variable cost, total cost is $4.50. So that's all there is to it. So it's just this plus this equals this. This plus this equals this plus this equals this. And that's it. All right, now the average costs. These are important for a couple of reasons. For economies of scale, where to produce, and we'll get into all that right now. All right, so let's just set these aside for a second. We'll just kind of separate these out. And now we're looking at this, the average fixed, average variable, and average total. We'll get to marginal cost in a minute. All right, so we have average fixed cost, which is fixed cost divided by output. So it's $3. $3 of fixed cost divided by 1 is 3. 30 cents divided by 1 is 30. And so the total average total cost is now $3.30. All right, the next day you come in, your fixed costs don't change because it's $3 every single day. But now we're making 2 units of lemonade. So now what we do is we divide the fixed cost, which is $3 every single day, now by 2. So you get $1.50. The next day you come in and it's still $3, but now it's divided by 3. And the next day it's still $3 now divided by 4, and so on. Average variable cost is the variable cost divided by units of output. So you can see here on day 1 or 1 unit of output, what happens is the variable cost is 30 divided by 1, so your average variable cost is 30 cents. Then the next day, your variable cost here is 80, so you divide it by 2 units of output and you get 40 cents. Next day, I already said this one, but it's $3 divided by 3, so your average fixed cost is $1. Then your variable cost is, in this case, is now $1.50, and so your average variable cost is $1.50 divided by 3, which equals 50, and so on. And there's a couple ways to calculate this, and it just, I think, sort of depends on how your brain works. And you know, some students find it easier just to add this plus this. I mean, you still have to calculate what this is because you have to say, okay, I have a fixed cost of $3. It's divided by 3 units. So now my average fixed cost is $1. Same here, $1.50 of variable cost divided by 3 units. So I have 50 cents of average variable cost of 50 cents. My average total cost, and you can kind of do this either way, but maybe for me it's probably easier if you add the average fixed and average variable cost, you get the average total cost. You can also take the total cost and then divide by the number of units of output, and that will give you the average total cost. It really depends on your brain, I think, and how it works. But anyway, that's the basics. And the big point here is this, and the reason why average costs are so important is notice what's happening to the average total cost is that as we produce more, the average total cost starts to fall. It falls for a while, and then it reaches a certain point, and then it starts to rise. That's important because what we can glean from that is when our average total costs are the lowest. I'm sorry, I hit the wrong button. Average total costs are the lowest. It tells us something about how we should be producing, which we'll do right now. All right, next we have the average total cost curve. So this is just the cost curve that we gleaned from the previous table. And so let me kind of just go through this real quick. So the first, day 0, we had a fixed cost of $3. On day 1, we had an output of 1, and now our variable cost was 30 cents. Then the next day we come in and we have an output of 2, and our variable cost was 80, and so on and so forth. And so it's just this average total, the total cost curve is just rising at an increasing rate due to diminishing marginal product. And that's all it is. All right, so now we go back to the next slide is going to show us all of our cost curves in a row. Oh, this is important because what happens here is this is all the average cost, the average curves spelled out in a graphical way. And let me kind of go through with each of these so that it's kind of clear, and be ready for a quiz question here. All right, so the average fixed cost is the first one, I think. Yeah, it was just the $3 divided by 1, divided by 2, divided by 3. And so you can see here the average fixed cost curve does something kind of unique, and that is that it falls really quickly at first and then continues to fall, but at a decreasing rate. And that's this right through here, right? So this is $3 divided by 1, divided by 2, divided by 3, divided by 4, divided by 5, and so on and so forth, divided by 6. And so what happens is this curve continues to fall forever. The more production you have, the lower incrementally the average fixed cost will be. But of course, because it gets divided by 2 at first, and then by 3, and then by 4, and then by 5, it falls quickly because it's cutting it in half first, and then in thirds, and then fourths, and so on. So it falls really fast at first, and then continues to fall forever, but at a decreasing rate. Average variable cost increases at an increasing rate. So the variable costs will go up, average variable cost will increase faster and faster and faster because of diminishing marginal returns. Here's the important part of this, and I'll kind of put it all together in just a second, is the average total cost is just the summation of the average variable and the average fixed cost. It's just this plus this equals this. So what happens is because the average fixed cost falls really fast at first, and again continues to fall but at a decreasing rate, what happens is the average total cost is really impacted at first. It's really showing up quickly. The average fixed cost is really driving the average variable and the average fixed cost total. Does that make sense? So here's the average variable. It's really low at first. This is really high but falls fast. This is rising at an increasing rate. And that, again, the average total cost curve is just the summation of these two, of the average variable and average fixed cost. All right, so the average total cost falls really fast at first because it's being more affected by the average fixed cost. There comes a point when the two intersect, where the average variable and the average total cost intersect. It, because of the relationship between the two curves, and this one meaning the summation of this plus this, is that at the intersect, the average total cost curve bottoms out because it's been more affected by average fixed cost for a while, and now it's starting to rise because average total cost is rising faster than average fixed cost is falling. I was going to break this video into parts because of the length, but I think we've only got 2 more slides, so I think I'll just try to finish it up and get done with it. Okay, so the cost curves and their shapes. I just went through this, but basically make sure you understand this. Is the average total cost curve is U-shaped because it's being more impacted by average fixed costs falling than average variable costs rising. Average total cost curve falls at first because of the larger impact, the quick decrease of the average fixed cost. And then what happens is the average total cost starts to go back up because the average variable cost is rising faster than the average fixed cost is falling. All right. And then I'll try to, one more slide. And we'll talk about marginal cost as we get into the firm. So the marginal cost curve crosses the average total cost curve at the efficient scale. And the efficient scale is where the average total cost curve has bottomed out. And there's more of that coming in the next, when we get into into perfect competition. All right, done with this. I will see you in just a little bit.